Hey, I'm Aditya Bihara, and this is my Physics 2211 Lab 4. In this lab, we'll be investigating an object oscillating at the end of a spring in the x and y directions. No net outside force will be applied after the initial, but the forces of gravity and the spring force will be applied on the mass as it oscillates. We're going to explore the changes in energy involved. This lab will use Tracker to measure actual data of a mass oscillating on a spring. Then we'll use GlowScript to create a computer model to predict the motion and energies of the system. Then we're going to compare the measured data to the predicted data. In this experiment, a mass is hung at the end of a spring and pulled back to initiate an oscillation along the x and y directions. The initial conditions are the cart mass is 0.402 kilograms, the initial time is 0 seconds, the initial position is negative 0.119, negative 0.617, 0 meters, the initial velocity is 0 across the board, the spring constant is 6.83 newtons per meter, and the relaxed length of the spring is 0.123 meters. Here is a video of the object at the end of the spring being tracked in Tracker. In this lab, we're going to use the equation delta E equals delta K plus delta UG plus delta US, and all that will equal 0 because the changes will cancel out. The change in kinetic energy is 1/2 mv final squared minus v initial squared. The change in potential energy due to gravitation is mgy, and the change in potential energy due to the spring is 1/2 m final displacement squared minus initial displacement squared. We're also going to use the net force equals the force of gravity plus the force of the spring, which also equals 0. Fg will equal negative mgy, and Fs will equal the spring constant times L minus the relaxed L0 times y. And we're also going to use the position update and velocity update equations. As you can see, I've inputted the mass and the initial position vectors and velocity vectors for the ball. I have also set the time to 0 and the delta t to 1/210. I've also set the spring constant K to 6.83 newtons over meters and the unrelaxed spring length to 0.123 meters. I've also done some basic equations to find L hat, and S, which is the displacement. I've set K to 1/2 mv squared, potential energy of gravity to the ball mass times G times the position Y. I've set the spring potential energy to 1/2 K times displacement squared, and then I'm adding all that up with energy equal to K plus UG plus US. In each calculation loop, I am finding the initial energies. I'm finding F net by finding the force due to gravity and the force due to the spring. I'm also using the update formulas to update the ball's velocity and ball's position vectors. I'm recalculating L hat, and the displacement S. And then I am recalculating K, UG, US, as well as their delta versions. And I'm adding all that up to find E and delta E. And here is the output for GlowScript. As we can see, the energy principle is satisfied because delta E, the change in total energy, equals 0, as the change in kinetic plus the change in gravity potential plus the change in spring potential all add up and cancel each other out to equal 0. I calculated the average oscillation period for x and y by looking at the 4 full middle oscillations and averaging those out. I got 1.625 seconds for an average oscillation period for x and 1.5 seconds for the average oscillation period for y. The difference impacts the calculations for the spring constant K, spring force, and the spring potential energy. I believe they could be accounted for by drag or user error, since I was just kind of estimating for where the oscillations ended and began.